Today, I'll show the proper way to repair the rusty frame on my 1985 Toyota pickup by cutting out the bad and replacing with new steel. A while back, you might recall I made a hammer test video on this truck, and it failed. Link to that video in the description. I already replaced the inner sides of the boxed frame from the cab back about 10 years ago. Now it's rusting through farther up beneath the cab. So here we go again. The first thing I need to do is get all these lines out of the way. Snip you. Let's see if I can save this bolt. I'm sure it's rusted on. While the PB blaster soaked, I got to work disassembling the parking brake cable. And of course, it was seized together as well. Special shout out to the state of Ohio and Road Salt for helping make my videos longer. There's a metal pin that should slide right out to release the cable from the bracket, and of course, it wouldn't budge. Okay, so that bolt snapped off anyways, and I finally got the cable out of the way from this front bracket. Now, I pushed these lines up out of the way. This plastic one is a breather for the rear diff, and I just zip tied them up out of the way for now. This brake line's a little in the way, but I'll work around that. Now, I can start cutting out the bad area. Notice how that sounds kind of hollow? Listen to that. That's solid metal. So right around here is where it gets bad. And this section of the frame may have been thinner from the factory. Now it's really thin, 37 years later. So I'm just gonna cut it all out. But first, there are a lot of frame repair videos being done the wrong way. I am by no means a professional fabricator. I'm just a guy in his residential garage with the 110 MIG welder. But as you may have seen in this truck's previous frame repair videos, which I'll link in the description, if you take time to cut out, remove, clean, and weld in new steel, the repair will last. And if I can do a proper repair with my little welder and my limited tools, then I hope you'll give it a try too. I've owned a lot of Toyotas with bad frames. How's the frame look?
Today we're going to show you how to do CPR on a broken frame. And it doesn't work.
And we know by now that these frames start to rust and rot away from the inside out. Once the inside of the frame starts to scale, separate, and fall off, those rust chips sit inside the bottom of the frame and hold moisture. Then add in mouse nests, acorns, and years of dirt and mud from every time the truck was driven off-road. All those things sit inside the frame and stay damp, which only causes the frames to rust even faster. That's why the most overlooked part of a proper frame repair is cleaning the debris out from inside of the boxed frame. And I'll show you how to do that in a little bit. But first, let's see how not to repair a frame. If you remember the red 1987 four-wheel drive I had a few years back, the frame looked solid at first glance, but someone actually welded angled steel right over the rusty areas of the frame. This is only a quick band-aid repair, and it will actually cause the frame to rust even faster in the long run. As soon as you see the first sign of a hole in the frame, or if it fails the hammer test, you already have debris inside of the frame from years of corrosion. When someone slaps a steel plate over the existing frame or welds angle iron on without cutting and cleaning first, the accumulating debris that accelerates the rusting is still there and will only get worse. There's a lot of videos showing people doing that type of repair. Please don't if you want your truck to last in the long run. I even saw a YouTube video where they put Bondo on top of the welds to try and blend in the new steel they welded on top of the old rusty frame. And they were proud enough of their work to share that video. And that's why you have to examine every inch of the frame if you're buying one of these trucks. But let's continue on with the right way to repair a boxed frame on a Toyota truck. Tool of choice for cutting out rotten sections of frame is the cutoff wheel. I have a brand new disc here, but they're bigger in diameter when they're new. Half-used ones can get into tighter spaces. I set a piece of sheet metal above the frame so I wouldn't blast the underside of the cab and the fuel lines with sparks. Look at all the crud starting to fall out of there. Didn't quite cut all the way through up here. And it's stuck down here too. Definitely wear gloves, or else you're guaranteed to get tetanus. And look at all that rust. This is just pieces of frame. And it just sits in here and holds moisture. Oh shit, I have holes in both sides. I didn't even see that before. Yeah, sounds pretty thin. Look at all that. This must be where two frame pieces were welded together from the factory. And there's a brace inside here. And that's really what caused a lot of the rust. On the other end, I'm going to cut this back farther, all the way to here. Because look how thin this part of the wall is down here from rusting away. It should be about twice as thick. But up here, I have a very solid area to weld to. Get this out of the way. Let's take a look inside the frame and see how much debris is in here. Ugh. This all has to come out. This is why you don't just weld on angle iron. These are some huge chunks of rusty frame. This looks better, but there's still a lot back there. And then toward the front of the frame, a lot of gussets in there. It's worse. Much worse. Look at this support brace. The whole thing is bulging in from the rust expanding. I've seen a lot of rusty frames, but that's crazy. At this point, it's doing more harm than good. I need to get all this out of here. I did not think it would be this bad in here. Look at this. It's like 3/16 of an inch thick. This brace must have just held moisture against the frame wall. Next, I got to work removing what was left of the rusted brace. It did put up a little bit of a fight, but it was pretty soft thanks to all the rust. I broke the back half off first. Then I was able to get behind the rest of the bracket with a big chisel and a pry bar. Alright, so far, here's all the rust that fell out of the frame. And we're just getting started. Looking toward the front of the frame, I still have more of this brace to remove. This other side of the frame is just paper thin right here. And there's the rest of that brace. I want to cut all the way to this corner, but I can't get that close with the cutoff wheel. So it's time for the Sawzall. This was a little sketchy at first because the blade wanted to kick around, but once a groove was started into the surface, it was easier to keep the blade steady and cut through the wall. I kept pausing to spray the blade with oil to keep it lubricated and cool. Get you out of the way. This is pretty heavy surface rust on the inside of the frame here. I have a die grinder here with this 3-inch sanding disc attachment. I'm going to use this 40 grit disc to clean up the edge I just cut. Now that I cleaned up that edge with the sanding disc, I have an 80 grit flap wheel. And I'll use this to get inside the frame and clean up a little bit of this surface rust. Here's my assortment of wire wheels. This is good for a frame. It's getting pretty beat up though. This one's brass, kind of soft for heavy rust. This one will be good for rust. And I also have a wire brush. And I can use this to get inside the frame where I can't reach with the drill. Here's how it's looking now. Got the worst of it off. Here's looking inside the frame to the back. And here's toward the front. Look at all that debris. The frame's like 1/3 full of rust. So looking farther up on the frame here, there are some holes in the sides. And another one here on the outside. I can feel chunks of rust in there. I tried using compressed air to blow some of the rust back out through the opening. And it worked for some of the finer dust, but all those big chunks were too heavy and lodged in the bottom of the frame to budge. Well, that didn't really do much. All these chunks are lodged in between all this bracing. And it goes way back. Time for plan B. So here is my homemade frame cleaner. This just connects to the shop vac, and duct taped to the attachment is a piece of garden hose. And up at the tip of the hose, I cut it at an angle. And this way, the opening's bigger to pick up some bigger pieces of rust. Let's get started. This was a long process. I could feel the smaller chunks of rust getting sucked through the hose and hear them landing inside the shop vac. But every few seconds, a larger chunk of rust will get stuck in the hose opening, so I'd have to pull the hose out of the frame and pull that chunk out of the hose opening by hand. I repeated this process for about 2 hours. Here's how it's looking so far. A lot better, but still not done. You can see there's a lot of gussets in the way, and those bolts that go through the frame for the cross member. So I really have to work to get the hose around all those things to get the rust way back there. There's still a lot left farther back. And here's a look toward the back of the frame. I've got that all cleaned out. With the worst of the rust removed from inside the frame, I tried the compressed air again to see if I could blow some of the debris closer to the opening. And I honestly can't tell if that made any difference. Oh, what's that? Way back there. It's the light at the end of the tunnel. That's all the way up where the frame curves up for the front suspension. There's that hole right there. Here's a look at the mouse nests and nuts that I vacuumed out of the frame. And this is only what's too big to go into the shop vac. A lot of tetanus in here. Gross. Once again, don't just patch over the frame. You gotta cut it open and clean it out. So here's the 1/8 inch steel that I'll be using to weld over this area here. But I also have the outer wall of the frame to repair. And if I weld this side on first, I'll have these sliders to work around on the outside. And these are welded to the frame. So I don't know if I'll have enough room in here to weld the top of the replacement panel. And I really don't want to have to remove these sliders. That would be a lot of time and a lot of grinding. I have good access to the bottom, but the top will be tight. So I'm going to weld this side in first. And that way, with this being open, I can weld from the inside if needed. Now, normally, if I were to cut out both walls of a fully boxed frame, the top and bottom rails would get real flimsy and probably bend some. But because I have the sliders welded to the frame on both sides of the repair area, that really beefs things up. I drilled into the outside wall here to see how thick the steel still was here. And as you can see, it's still very thick at the top. I stopped drilling because I was already 1/8 inch in. So I'm just going to cut out this lower area, which we know is paper thin. See, that's what good metal sounds like. Hear the difference? So there's no point in cutting out this entire wall when I only need to replace the lower half. So let's get started on the outside first. Hopefully your frame is only bad on the inside or the outside. I get to repair both on mine. First, I'll throw a light coat of primer over this, or any old paint will do. And this is just so I can see the lines I draw with a Sharpie marker. All right, that's had about 10 minutes to dry. It's not laying down flat. I need to flatten the edge of these rust holes a little bit. That's better. And just hold it flat and draw around the perimeter with the marker. I already had this piece of steel from another project, and it's perfect for this repair. Next, I used the cutoff wheel to cut just inside of the black line I drew with the marker. Cutting metal is a subtractive process, so I'd rather not remove enough material at first and then have to take a little more off later, than remove too much on the first cut and have the cutout be too large for the replacement panel. I can look at this piece I cut out and see it was really thick on the bottom still, and on the side, and on top. Just a little thin in the middle here, where the rust was getting bad. It's amazing the way these things rot out. My cuts weren't perfectly flat, so I evened them up with a file. After a little bit of filing down the cut, my new piece of frame fits like a puzzle. The upper corners of my cut turned down slightly on both sides, so rather than try to file that straight, I just took some material off the top corners of my steel plate. That was a lot faster because I could use the bench grinder. To hold the metal in place while I weld, I'm going to use a magnet. You saw me use this in the front knuckle rebuild videos of this truck, and also when I replaced the burr fields on the 80 series. It has a knob to turn it on and off. It'll hold this steel in place, no problem. Whoa, too strong. All right. Nice and flush. You might have noticed the arrow facing up on the outside. That's so I can tell which side is facing up. I always want to have a flat edge in the same place when I'm test fitting this thing over and over, removing material here and there to get it to match the shape of the cutout. The arrow lets me know which side to remove the material from, so I don't spin it around or flip it over and take metal from the wrong side by accident. Now I need to grind off the paint from the edges here so I can get a clean weld. And to do that, I'm using the angle die grinder with the 40 grit sanding disc. If you don't have a die grinder, this can also attach to a drill. I couldn't really get this edge because the slider bracket is there. So I'll use my ratty old wire wheel attachment to get that edge. Now I have some clean bare metal all the way around the perimeter of my weld area. I'm going to clean the inside of the opening too. I used the wire wheel to clean the perimeter of the opening on the inner rail of the frame while I was at it. So when I weld the new panel on the outside of the frame, I may need to weld the top from the inside because the sliders kind of block the outside. So I went ahead and cleaned up the edge of my steel here, and I did the outside too. I still need to clean the bottom. And I just run the edge on the wire wheel on the bench grinder to clean it up. Then, after the outside piece is welded on, I can weld this inside on because I should have some more room to work in here. So I'll do this one last since I know I can weld this one all the way around from the outside. I still need to do a little trimming on this piece to get it to fit perfect. I gave the inside of the frame another quick cleaning to remove any debris or dust I added by cleaning up the edges of the openings. It's finally time to weld. I bought this Lincoln in the mid-2000s to weld quarter panels on my Civic. It's perfect for sheet metal, but it will work for this 1/8 inch steel if I crank it up all the way. It's only 120 volt. 1/8 inch is probably about the max thickness I'd try to weld with this. Got plenty of wire, and I'm using argon shielding gas. You could do flux core, which doesn't require shielding gas, but it's messy. Lots of spatter. And this cylinder is almost empty. See the needle barely move there? And 16 liters per minute. By the way, I'm not a professional welder or fabricator, so if I could be doing something better here, let me know in the comments. But this has always worked for me. And auto darkening helmet, worth every penny. Proper safety equipment, long sleeves and pants. Oh, and I have a fire extinguisher handy just in case. I am welding near some fuel lines under here. I have an old piece of sheet metal here, and I'm going to use this to block these fuel lines from any sparks. I also made sure to run the gas down real low. Well, it's off right now, but I did let the gas get just down below E, just in case, worst case Ontario. I got the rest of the edges cleaned up on the wire wheel, Now the new panel is in place. So I'm going to do some tacks here around the edge first, just to make sure nothing moves on me. There's that piece of old sheet metal I have sitting up on top of the frame to keep any sparks from flying around where I don't want them to. For the ground, I just ground some paint off this tab here for the bed mount. I've got this cranked all the way up to D, and we'll try 7 to start with for the wire speed. Looks like D and 7 are a decent combo. That one's weak. I might try a little less wire speed. See if I can get a little deeper. A little more penetration, as they say. Alright guys, well, I had some decent welds. Missed some spots. I had a really hard time seeing what I was doing. Welded through there. Missed a spot there. Missed a spot there. Oh wow. Alright, go ahead and make fun of me in the comments. I can't say I'm proud of these welds. I was sure some of those didn't penetrate well, so I decided to grind those boogers down for a closer look. The frame is structural, so a good weld is necessary here. I'd rather do it twice than have my repair area crack down the road. I'm glad I did that because there are some areas that didn't really get welded together. You can see a tiny crack there. It's like less than the width of a hair. Need to re-weld that guy. Here's a bigger one. Before I weld on the inside of the frame, I have a drill here. And I'm going to drill an additional drain hole and enlarge the factory drain holes as well. And I'll add one up here too. The frame curves down here and then curves back up. So all that debris settles here in the middle. Some larger holes should help prevent that and make it easier to clean. The first hole was where the frame flattens out after the front leaf spring. The idea here is after submerging the frame in mud, I could park on a hill and power wash the inside of the frame from the back, and it would drain out from these holes. Then I enlarged the hole with the biggest drill bit I had in my toolbox, which was 11/16. I drilled another hole in the center below the repair area, and I enlarged the factory drain hole at the rear to 11/16. Next, I did any final trimming to get the inner panel to fit perfect, and that included slightly curving the bottom edge to contour the lower edge of the frame. I heated the metal and hit it over the edge of a vise with a hammer to get the slight curve. I used C-clamps to hold this piece in place. It was too heavy for the magnet. This edge is good. The top is nice and flush. But back here, if I push this in, flush with the bottom, then the top moves in a little farther than I'd like. So I'm going to weld across the top edge first, and then I'll clamp and weld the bottom. And there she is. I'm a little happier with how this one turned out. The bottom is tricky because I'm welding upside down, and hot metal tends to fall down on me. So I turned the wire speed up to 8 for that. But I'm going to grind these down and get a better look at them. I'm glad I did that because, yeah, I could get in there a little better. Missed a little spot there. Definitely going to weld more up here. I was almost finished welding that bottom edge and I ran out of gas. Almost perfect timing. When you run out of gas, you get a lot of spatter and the welds get these holes in them. No bueno. So there's the final product. She's solid once again. Check out the outside. And now I need to protect this new metal. I've used POR 15 in the past, and for as expensive as it is, I feel like it doesn't hold up as well as I hoped. For one, it's not UV resistant, so it seems to degrade over time. You see it peels off kind of easily, and there's rust underneath it. I need to recoat the entire frame, but I'm not sure if I want to go with POR 15 again. If there's a product that you guys like, let me know in the comments. Maybe I'll try that in a future video. But for now, just to protect the new bare steel, I'm going to hit it with some degreaser first. I'm a fan of prep spray. Brake cleaner will also work. And then I'm going to coat it with some self-etching primer. I'll put links for these in the description, by the way. And this is ideal for bare metal. And I have a couple of options here. This one is VHT, roll bar, and chassis. Self-priming, all-weather, rust and corrosion resistant. And even though it says self-priming, I like to prime anyways. Same with this epoxy paint by VHT. Pretty much the same features and temperature. Again, I'd still apply primer first. Even the instructions on the back of these are the same word for word. So I'm going to use one of those. I considered this one Duplicolor Rust Barrier. All the features sound ideal until I got to this last one, Flexible Rubberized Finish. And that's typically a feature of a product that you don't want to use on a frame. And I'll tell you why in a second. But first, let's look at products that should not be used on a frame. Anything that is a rubberized coating, or like your truck bed coatings. These are all applied thick and have a rough or lumpy finish. And that's bad for a frame because if a rock chip or road debris penetrates through the flexible rubberized undercoating and moisture gets behind the coating, it will rust. But because the coating is already bumpy, you might not notice the rust bubbles until it's too late and a small repair becomes a bigger one. I've seen already rusty frames that people coat with this stuff, thinking they're stopping the rust or slowing it down, but this will actually make it worse. So don't put these on frames. Let me know if you've ever used this rust barrier. I'm curious how it holds up. But right now, let's go clean the frame. Gonna want a respirator because this is potent stuff. Yeah, look at all that dirt and grease from just one pass. Let's do one more. And now the self-etching primer. And then I applied a second coat to be sure I covered any irregular surfaces of the welds. Then one light coat of the epoxy paint, followed by another light coat of epoxy paint, and then one medium wet coat, which you can see cause a couple runs, but it's on the inside of the frame where they won't be seen. Okay, it's the next day, and the epoxy paint has dried to a smooth, gloss black finish. And the bottom of the frame as well. And the outside, the gloss black really highlights my poop welds. It's not like it's going to SEMA. Well, now I've protected the outside of the frame from corrosion and rust, but I didn't paint the inside because it will eventually flake off and collect in the bottom with other debris and cause more rust. That's why I prefer fluid film. I'm a fan of fluid film. You've seen me show how to coat the underside, as well as spray inside quarter panels, fenders, rocker panels, and doors to help prevent rust. And now I'll show how to coat the inside of a frame. I ordered some aerosol cans from Amazon. I'll put the links in the description. And I'll also put a link for this attachment. It's a long, flexible wand, and it has a tip with 4 holes that spray the product in 4 directions at once. So put the wand inside the frame hole, and when it's all the way in, give it a spray and pull it out. Then do the same going the other way. I bought a gallon too and poured some into this old bed liner spray gun. And then I went back and sprayed a liberal amount of fluid film mist into every hole on the frame. And then I reconnected the emergency brake cable. And that's how I fix a rusty frame. If you have any questions or have a different repair method, let me know in the comments. Consider subscribing for more how-to videos and project vehicle updates here at the 6th Gear Garage. Thanks for watching.